Hello. We are about to talk about lesson 4 in fuzzy sets qualitative comparative analysis, or fsQCA. I'm Arch Woodside. I'm a retired professor at Boston College, and it's good to see you again. And let's get started. I'm going to share the screen and move to a couple slides here, and we're going to look at some more basics in using the software, fsQCA software that was developed by Charles Rajan. By the way, there's 2.0, there's 3.5, then there's 4.1, and they're about the same, but there's some slight improvements in each of them. I'm using the basic one, I think it's 2.0, called 2.0. Yeah. And so what we covered on lesson 3 was these steps. Open Excel spreadsheet, record your data, and we recorded data, and we save the data. We close the Excel spreadsheet, and you really need to do that because you can't save things unless the Excel file is closed. You can't save things in fsQCA. So you got to close your Excel file, open fsQCA, open your data file, calibrate, test your theoretical models, test your abductive models, and what I call abductive models. And we're going to do that today, and then test for robustness of your models, and that's we can talk about that today as well. So this is the example of the data that we're working with, and today we're going to work with the full data set. We worked with 6 cases last time as a way of introduction, first time using fsQCA. I want to mention what consistency means. If we go back to, you see at the bottom here, the total scores for the across the 6 cases for the model being low price, no pal present, and an expert message by the salesperson. It sums to 1.4, the scores for the 6 people, and the minimum score for the 6 people is simply the comparison of the model scores with the outcome score. And so the minimum score of these two, 0.99, 1.0, so the minimum score is 0.99. And the minimum score, for example, for case 2 is 0. Both of them are 0. The minimum score for case 3 is 0.50, and so forth. All right. So if you look at the footnote down here and look at the minimum score divided by the total score for the model, that's the measure of consistency. That's how consistency is computed. Now, the program computes it for you, but what you'd like to see is the consistency score to be above 0.8. That's the benchmark, typically 0.8. You can go down to 0.7. Basically, what that's referring to is that if you achieve a 0.8 consistency, your odds are 4 to 1 that if you're high on X, you're going to be high on Y. So out of 5 cases, 4 of the 5 cases will be high on Y for a given model that where the cases indicate 0.8 or higher consistency score. And coverage is the for example, 0.37, that would indicate about a third of the cases that are high on Y or high on X. All right, so coverage is looking about the power of the model across the cases in terms of the cases high on Y. And so if I escape from this for a second and look at consistency, what that means is that if we draw a little picture here, and this is Y. Let's see if I can get the Y here. This is Y, and this over here is X. And if you're consistent, so for the cases that are, say, high on X, most of them would be also high on Y here. So consistency, you're comparing vertically here. So cases high on X, here we have about 3 cases that are low on Y. We don't have perfect accuracy is what I'm saying here. But if your consistency score index is 0.9, that would mean about 7 out of 8 times you would be high on Y for the cases high on X. A perfect accuracy would be a consistency of 1.0. All right, but if you're thinking about coverage now, the coverage index would indicate that among the cases that are high on Y, what's the share that are high on X? So coverage refers to the power of the model among the total set of data, and consistency is accuracy, okay, and coverage is power of the model. So the main thing that you want is to make sure you have an accurate model. And all right, so if we turn to coverage and look at coverage here, let me see if I can find a drawing here for well, we've covered coverage here, and coverage again is cases that are high on X and high on Y. These cases over here, if we had this situation where we had more of the cases over here than over here, that would mean our coverage would be like 0.6 or 0.7. So the very powerful model for indicating all the cases high on Y. All right, so what we're going to look at is this set of data. Now, this, and we're just going to look at the first 3 prices, and we're going to skip the last price in terms of entering the data. So we got 30 cases in for $1.98, and 30 cases for $2.98, and 30 cases for $3.98. And our data from a true field experiment, the salesperson speaks to 150 customers, and he either gives an expert message or a non-expert message about a new product. And below is the first 60 cases, and I simply took that from these 30 cases and these 30 cases. So you can do that yourself to come up with your data. And so the first column is case, the second column is price, the third column is PAL, fourth column is expertise, and whether or not they bought. So you would open up a spreadsheet and put in the data. And we're going to get to this type of an output. So I'm going to shift over from this to the Excel spreadsheet. And let me do that right now. 1 second. So here's the spreadsheet, and I have put in the data in my spreadsheet, and the first 5 columns is what we said. Now, you know, I said that the program sometimes is a bit cranky, so you have to make sure that you have calibrated data, not just the 1 and 0. So I redid price. You know, price goes from $1.98 to $2.98, and if we go down here, it goes to after the 60th case, we go down to $2.98 down here, and beginning at the 61 case. And so I coded the 61 case would end up being a 0.5 price, because it's the price in the middle between $1.98 and $3.98. And then I also coded the PAL, and I coded that, and I'm going to go over the coding again so you see how that's done again. And I calibrated PAL, and I calibrated expertise, and I calibrated by, and here they are over here. So I'm going to, so I'd like you to actually create a Excel spreadsheet, and that becomes your data file, and you put in the 5 variables, the case number, the price, PAL, or present or absent, expertise, present or absent, and then PAL. And then you close it, and then you open up your fsQCA program, and then click on File, and then open that to Data, and then I'm going to open up my data, and there's the data, the same data that we had before, but now it's in the fsQCA program. And then I'm going to show you the calibration again, and let's go ahead and calibrate PAL, for example. And you click on variable, click on compute, and then click on calibrate, and bring it up to the expression line, and then click on PAL and put it right after the first parenthesis, and then skip over the comma to the 1.0. That would be the high value for PAL, and that would turn out to be a 0.95 then for PAL. And then skip over the comma, put down 0.5. We don't have any cases 0.5, but that's okay. If we did, where it would be somewhat expert, they would get a 0.5, but we don't have that. But you need to report the possibility of for the maximum ambiguity point in the middle. And then skip over the comma and put down, you could put down 0.0 for the full membership in full non-membership in PAL. In other words, PAL is absent, and then write down PAL CC, and I did, let me spell it correctly, PAL CC, because we already have a PAL C. C stands for calibration, and here I'm using it for calibration. Click OK, and there it is. There's PAL, and it's the same as the column for PAL C. I'm not going to bother to do expert C and by C, you do it the same way. And I'm going to go ahead and do price C again, because just for practice for you to see it. So I'm going to do variables compute, and I'm going to get rid of this, and we're going to put it in again and calibrate, and we're going to calibrate price. Bring that up to the expression line, skip over the comma, and then you put in the high price, which was $3.98, and then skip over the comma, and then put in the middle. You always put the high price or the high value in first, and then the value for the maximum ambiguity second, then skip over the comma and put the value for the start of full non-membership in third, and this is price CC. Okay, and I'm going to say okay, and there it is, what I had before for price C. Now I just did it again over here, and that's okay to have it appear twice, just to make sure the name, of course, is different. Okay, so I'm going to save it. It's always good to save what you're doing. And now, look, we're going to do something we didn't do before. We're going to analyze, and this is, and before we analyze, let's go ahead and do a fuzzy statement again. And so this is actually model construction, compute for a model construction. So fuzzy and is just really, really important thing to remember and to play with. Fuzzy and let's say we have a very bad situation. We had a high price, so price C, and we had well, before that, let me skip that idea and say let's compute the negation of price. So we look for not X, fuzzy not X, bring it up to the expression line, put in price C, bring that up, put that into the value with the expression, and then put in not price. And then click on OK. And that gives us the top score is the low price, and the high score now is the bottom price. So, because this is the negation of price. And let's also do the negation of PAL. So if we did that, I'm going to save that, and then do the negation of PAL. So we can compute that. And so this is not X. Get rid of that, the old one, put in not X. There we go. And put in PAL. Well, the PAL calibrated. So this is not PAL. Okay. And there's not PAL. All right. And if we did the last one, that would be expertise compute, not expertise. Okay, and that would be not expert. Let's see, there we go. And Click OK. So now we have that. So now we can construct a model. I'm going to save that. We can construct a model using the fuzzy and statement. So get rid of that. And we go to fuzzy and so we're going to look at the compound statement, the configuration for let's say we can do not price, comma, and then we can do PAL present, comma, and expert as expert. So this is low price, PAL, expert. Okay, and now we click on OK, and we have the scores for people, and this is low price, PAL present, and expert. And person one, for example, we can just check that for person one, and so low price, let's see, I don't see low price, not price, there it is, not price, 0.05 price, and okay, not price, that not price should be high here, and it's not. So there's a mistake here. So this model is incorrect. And so that's a good lesson, though I wasn't planning on that. Because let me do it again. You see price here is low, and then not price should be low too. So look, I'm going to calculate not price again. Variable compute delete. And so this is not price CCC. All right, not price CCC. That's going to be equal to not price. Bring up not in the expression line. Put in price. Not price. Okay. No, there we go. No, not price is correct. See, 0.95. The low price is now the high value because it's the negation of price. All right. And now we should analyze, compute the fuzzy statement, compute where we have the fuzzy and condition. Fuzzy and condition. And so this is not price, I'll call it that. And then PAL present and expert present. I'll put down a C as well. All right, so, all right, now we have not price and PAL present. Remember your comma between the two, and then second comma, and then expert present, high expertise. There you go. Okay, and then click OK. All right, so now that's correct now. So this is the model of compound statement or configuration, complex antecedent. I'm going to save it, and let's see if the model works. All right, so we can graph that to look at the consistency and the coverage. And so fuzzy statement, XY plot, and the Y is the bi-calibrated, and the X is our compound statement. We can do a simple statement too, but here's the compound statement of a low price, and then case would be the identification for the dot on the XY plot. Wow, look at that, 0.93 as our consistency. So the model works very, very well. And now it looks like, we got some cases that are high on X, but low on Y, and that's true in real life. Not everybody bought, and we have a total of 2 cases represented by this dot. Okay, there's only 2 cases, but everybody else who got this model of low price, high PAL, high expertise, they ended up buying. And if we look up here, we have a total. We have, let's see who bought. All these cases bought here. There's 5 cases, and it looks like we have about 14 cases that bought. We can count them up. 14 versus 2. So the odds are 7 to 1 that if you got the model, you're going to be high on Y. And if you look at coverage down here, 0.257, that indicates the 14 people represent about 1/4 of the total people who are high on X, who are also high on Y. So there's the majority of people were not high on the model, but they're high on some other model who ended up buying. And so that's rather interesting too. It relates to complexity theory tenets that we need more than one model. We're going to find more than one model that works. And that's called the equifinality principle. So try to use that in a sentence sometime later today or tomorrow with somebody, I don't care for example, I don't care which we do, what we do, have dinner at a restaurant or go to a movie, they both sound wonderful. So more than one solution would be reached. And also there's more than one model for a given solution. So here it's a case of there's more than one model that would be useful to get us to a purchase decision. All right, so that would be a type of analysis. But look, there's something else we can do too, and that is we can actually do the analysis. We don't have to do it by hand. The computer will do it for us. So if we close this, go to analysis now, and this is the heart of the analysis, the heart of the use of fsQCA in some ways. We clicked on fuzzy truth table, and here we specify what our outcome that we're looking at, and is by is our outcome. And then we're going to look at price, and then PAL and expertise, all calibrated. And click on run. And this is called a truth table. You need to edit your truth table. I'll explain to you what it means in a second. So click on delete and code after you click on edit. And here you can you can test different requirements of the model, such as you want to have at least 3 cases in a row for models that work, and you want to test for higher level of consistency. You want to say you only want models that work at a 0.9 consistency, or odds, for example, of 7 to 1. But typically the benchmark is 0.8, so leave that alone for now, and let's click on OK. So these are the models that look like would work to give you high accuracy. And you see this first model where no PAL present, which is okay. PAL present or absent wasn't a big deal in terms of the outcome. Well, I actually got this in twice here, so we got to redo it. Let's redo it right now here. Analyze, fuzzy truth, and we got by not price. Actually, we don't need to do that either. We can just put in analyze fuzzy truth. We can put in by is our outcome that we're looking at, and then the price calibrated. It'll tell us in the output when you analyze whether it's negative or positive. In other words, high or low price, expertise, and PAL. All right, just those 3. Run. These are the models, and we're going to edit. Always press on edit here, and then delete and code. You can change these numbers if you want. We'll make this one 2, doesn't matter. You can make it 14, but that would be too restrictive of the number of cases that the model indicates are high. So, you don't have to change it at all, but you do have to click on edit. Click on OK, and now we got this is low price, high expertise, and then PAL present. There's 15 that fit that basic model that is represented by those 3 conditions in combination, and the model works very well. These are different measures for consistency. Okay, and any one of them is okay to look at, because they're similar in the index values. All right, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 models that have some cells are occupied in. Actually, there's only 1, 2. Let's see, the last 2, there's nobody in, so you don't have to think about that. But some journals like you to report your truth table, and you can look at some articles with the truth table, and we can do that in a later lesson. Now that we got to this point, we can this is we're going to do standard analysis, and so we've done that's standard analysis, and just click on OK when it asks you whether or not a causal condition should be present. Just click on OK, and this gives us our output here from the model here. Let me move this up and make this larger. So, and if you look at the output, here's the output from what we've tested. We have a parsimonious and a up here we can parsimonious solution and a intermediary solution down here at the bottom. typically you go to the intermediary solution. The complex solution will give you all conditions that you're testing for, and intermediate solution will be somewhat more parsimonious than that. I'm sorry. This is parsimonious. This is intermediary, and then there's a complex solution that gives you all the conditions possible that would work in the model. And the one that is you typically report in a journal article or in a study for a company would be the intermediary solution. But in this case, they're exactly pretty much close to being the same here. And let's take a look for a second at the solutions here. There's the first solution is right here, and it's PAL present, expert, and low price, and the model works very well. It's 0.93. The consistency and the coverage is 0.26. And then the second solution is no PAL and expert and high price. So, high price you can get to a sale, and low price you can get to sale. And that's the second complexity theory tenet, that you don't, that you have reversals and impact. So isn't it nice to see that a high price gets you a purchase? But this is a situation where the expert is present and there's no PAL present. So that's pretty cool. So let's close that and get back to the slides for a second from PowerPoint and go to where this is coming from. This is an article published, and you read about this. If you'd like to pull down this article, you can actually get to it, the article, that's what we just looked at in terms of output here. And you can clean this up, to what you can do in cleaning it up is get rid of this information up above here. Take that out and move over raw coverage, and you can actually get rid of this. Represents unique coverage in the middle, and get rid of these two here. Just report raw coverage, or get rid of the word raw coverage. You report coverage and consistency, and this is your coverage scores here. Right here is your coverage 0.25 and 0.22, and consistency is over here 0.93 and 0.84. And okay, so I'm going to just show you this. This is a logic diagram of what we've looked at in terms of starting. You might show this to a manager, that if a PAL is present and you use an expertise condition, you could actually end up charging a higher price and get the same sales result. But if the PAL is not present, you would still use the expertise condition, and you'd have to charge a lower price to get a sale, to ensure that a sale occurred. So managers can understand this quite readily, more so than just numbers on a page. So this article, that's the article that relates to the first 4 lessons, and you can get this in this journal, International Journal of Business and Economics. If you can't find the journal, write to me and I'll send you a copy of the article. Okay, and this is triple sense making. The first way is regression models which is not so good. It's actually bad science practice, and we covered that in lesson 6. I'm sorry, lesson 5. All right, so, and these two co-authors of mine were students in the course that they took on fuzzy set qualitative comparative analysis. So the takeaways today is enter the data in an Excel spreadsheet, save the Excel spreadsheet as a CSV, delete file, and then open your fsQCA, practice with the data set that you now have, graph your findings for your most informative fuzzy set models. And I'm not going to go back here, but I showed you how to graph your results. You actually have to have a column in your fsQCA file where you show your model and then and that's your X in your XY plot. Okay, so write to me if you have any questions. There's my email address, and it's really good to see you today, and I hope to see you for lesson 5. Okay, goodbye for now.